My name is Nicole Hawthorne, and my team member name is Alicia Smith, and we'll be covering the programming language called LISP. So, a quick introduction. LISP has a huge impact in the coding world with regards to artificial intelligence. Um, it has the ability to compute symbolic expressions rather than numbers, which makes it convenient for AI applications. Um, It has been noted as the background of innovative designs in recent study, and many of the concepts or features in Lisp can be traced to the functionality of other programming languages. So LISP, which is an acronym for List Processing, was developed by John McCarthy in 1958 at MIT, making it the second high-level language ever after Fortran the year before. McCarthy designed LISP with the goal of facilitating research in artificial intelligence. It was founded on the mathematical theory of recursive functions, and it's the first interpreted language that could be executed step by step without a compiler. And this is specifically suitable for tasks involving symbolic reasoning, such as theorem proving, natural language processing, and machine learning. It was first implemented on an IBM 704 computer using punch cards, and in the early years, LISP was popular in the academic and research setting, specifically in the AI community. And over time, the popularity of LISP in the industry declined due to the prominence of other programming languages such as C, C++, and Java. And after it declined in the 1990s, Lisp has experienced a reinsurgence of interest in the 2000s with the help from computer scientist and entrepreneur Paul Graham. He wrote an essay titled Beating the Averages, which detailed his interest in using Lisp within his latest startup organization software platform to create a competitive advantage over others.
Next few slides, we're going to be talking about a tutorial for a Hello World program. Normally, when you're learning any programming language, one of the first programs you learn will be Hello World. So when using Lisp, you will need two different types of software to create your program, a text editor and a Lisp executor. So first you have to set up your environment. And in the programming world, environment refers to tools used to use the program. It's referring to your operating system, your compiler, your debugger, the hardware, the software, everything. Text editors are computer programs that handle plain text, so Notepad, for example, and the Common Lisp executor is free to download, or you can download the CBCL from the website, but it costs a lot of money. Um, and once you set up your environment, you just need to build your program. So you'll start by opening your text editor and creating a new file. Whatever you want to name your file is fine, but you need to make sure you follow it with .lisp. And once you're inside your new text file, you'll type the following code. And this slide will give you a little bit of a breakdown about what you just saw. So the format is a built-in function used to produce formatted text. It's used to format any string, and it just makes your output look nice and neat. T is an argument that describes the destination of a text. So in our case, T would be referring to the terminal or console where the message will be displayed. And these symbols right here, it's the equivalent of inserting a new line character like you do in C++ at the end of a phrase. It's just telling the program to insert a new line after printing the string. So, to run the program using CLISP, the easiest way is just to use the command line. So open the command line, access your terminal, enter your source code name, or remember the .lisp, and then you just execute the program. It's really simple and easy. It's very straightforward. And this is another look at the program. The format T, hello world. Remember to enclose the text in quotation marks. And that's all for our hello world program. So next we'll be discussing a little bit of a more difficult program. So this program will demonstrate a task management system. So there's a daily increase in the reliance of technology in our day-to-day lives. So this program will allow users to manage their tasks as efficiently as possible. And so the user will be able to remove, add, or edit tasks as needed. Okay, so we'll start with the add task function. This function takes a task as input and adds it to the task list. It incites the push function, which adds all new elements to the front of the list. With this approach, each new task is given a higher level of importance in the task list. For example, if a user inputs finish report, the program executes add task finish report, which will create the list finish report. And if you come over here, you can kind of see where we define the function and pass the parameters. We'll talk about this a little bit later in the presentation. And you push the task in, and it'll print out the task. The remove task function removes a specified task from the list. First, it checks if the task exists using the member function. If the task is found, it modifies the list with the remove function. For example, when a user requests to remove finish report, the program will check for its existence first, and if it exists, the task will be removed. The view task function operates similarly. So this function iterates over the task and prints each task. It uses doList, which is a convenient construct in list, to display all current tasks. For example, if the task list contains finish report, email client, the output will clearly list each task line by line. And so here we get an example of the remove task and view task functions. And so we defined our function. We've set our conditional statements, and these two functions allow a user to either remove a task or view a task. And our main function contains the program's main loop, which manages user input and executes commands based on the user's choices. Within this loop, the program continuously prompts the user for commands until they choose to exit. The main loop accepts the commands such as add, remove, or view, and makes the changes based on the user's commands. And here we see our main function defined, and it gives the user the option to enter a command, add, remove, view, or exit, and it prints out accordingly. This is the rest of our main function. And one important detail about the LISP program is the global variable tasks, which is a list that stores all the tasks in the program. Lists are a very fundamental data structure in LISP. They provide dynamic sizing and easy manipulation functionalities. This program uses a list because a list allows for direct additions and deletions of tasks and the ability to iterate over the list for viewing. For example, when a user adds a task, the add function incites the push operation to insert the new task at the front of the list. Now we'll do a little bit of evaluation. With orthogonality and syntax, Lisp is known to be one of the most simple and most orthogonal programming languages. It's known to be simple mainly because of its minimalistic syntax. Lisp code consists of expressions, primarily lists, that are processed by the language's evaluator. The minimalistic syntax means everything in Lisp is either a function or a data structure, and both of them are treated as lists. Lisp is known for its simple syntax. Every Lisp expression, including function call, is enclosed in parentheses. There are a lot of parentheses. It is important to note that this can lead to the language being seen as difficult to read or navigate, especially when you first start out, but it does get better as you go along. The frequent nesting of lists can lead to a high parentheses to code ratio, which can be a problem as far as readability goes, but it just takes a lot of practice. As far as expressivity and type checking goes, Lisp is highly expressive. Its simple syntax allows programmers to implement complex algorithms and data structures in a concise manner. The language supports first-class functions, which means that functions can be passed around as arguments, returned from other functions, and stored in data structures. This feature is essential for higher-order programming and functional paradigms. Lisp built-in support for recursion, list manipulation, and symbolic computation make it ideal for programs that involve complex algorithms. It is important in the creation of artificial intelligence and symbolic mathematics. Lisp is also dynamically typed, meaning that type errors occur at runtime rather than compile time. This gives Lisp programmers more flexibility. However, it also means that type-related errors will not be caught until the program is ran, which can lead to bugs in larger systems and a longer runtime. In comparison to other languages, Lisp is often optimized for fast development. The dynamic nature of Lisp allows for faster iterations, while C++ typically outperforms both Java and Lisp due to the fact that it compiles much faster than both. Lisp dynamic typing can be a plus for tasks that require faster development since it allows for flexibility in the types of data being handled. C++ and Java use static typing, which catches type errors at compile time. This does reduce runtime but can greatly increase the time you spend on development. And while C++ and Java have extensive databases with numerous libraries for an array of tasks, Common Lisp has a much smaller database with just a few libraries. These libraries work best for symbolic processing, artificial intelligence, and other specified tasks. This makes Lisp particularly effective for applications in AI.
Going to discuss the most commonly used data types in Lisp. Every object is assigned to a data type. An object in Lisp represents data that is used and manipulated by Lisp code. Lisp has various data types. The most commonly used ones are arrays, numbers, strings, vectors, floats, and it can be grouped into two categories. So scalar types, which are the data types that are used to store single values. This consists of number types, characters, the symbols, float, and strings. And data structures are the data types that are used to store multiple values, such as list, array, vector, bit vectors, strings, etc. So type specifiers are list objects such as names or symbols that are used to identify the data type of an object. In Lisp, variables are not considered type specifiers because they are not assigned specific types. Below are examples of system-defined types that can be used in Lisp. You can see array, character, vector, string, and atom, which we'll discuss later. Some of the primary data types used in Lisp, um, it's atoms, numbers, characters, arrays, lists, vector structures, functions, and strings. So atoms are the simplest data types in Lisp. They represent a single value that cannot be divided, and they're used to identify symbols and constants, with the symbol being names used to identify variables or functions such as x, my function, and results. Constants include numbers, characters, and strings such as 42, pound sign, backslash a, and hello. LISP supports many numeric data types. It includes integers, floating point numbers, rational numbers, and complex numbers, which are numbers with real and imaginary parts, such as 2 plus 3i. So in this example, it shows numbers being used in LISP. As you can see, A is a number and it's set to 1. B is a floating point number and it is set to 2.0. And C is a floating point number, however, it's in scientific notation. So we'll just use move the decimal point 2 places to the right. And D is a complex number and it stores 1 and 2. And so we're going to print A is 1, print B, B is 2.0, and then we're going to print C, C is 400, and print D, and D is 1.0 plus 2.0i. And in this example, the complex is the type specifier for the complex number. So characters represent a single letter, digit, or symbol. And here's an example of characters being used in LISP. A is a character and it stores C, and B is a string and it stores geek for geeks. And here is our output. A is C, B is geek for geeks. So arrays store multiple values and are a collection of objects and lists that can be indexed by integers. They allow access to array elements through their index, but the array must have a non-negative number of dimensions, and vectors are also referred to as one-dimensional arrays and can store any data type, and strings are considered one-dimensional arrays of characters, while bit vectors are one-dimensional arrays or bits that can store only zeros or ones. In this example, the word vector is a type specifier for vectors. And the word array is a type specifier for arrays. And the word bit vector is the type specifier for bit vectors. And the same for string. String is a type specifier for strings. So lists are fundamental to LISP. A list is a sequence of elements that can be atoms or other lists that are enclosed in parentheses. Here's an example of a list. We have the 1, 2, 3 enclosed in parentheses, and also plus 1, 2 enclosed in parentheses. So functions are first-class objects in lists. They can pass as arguments, return from other functions, and be assigned to variables. This is a programming language that has a style that is organized around expressions in functions. So every list procedure is a function, and when called, it returns a data object that is a value. They are defined using the lambda keyword or the defunct macro. So LISP provides many unique structures for organizing programs. It can support different decision-making statements like if and cond. It can also support different iterating statements like do, loop, do times, and do list. So the if statement is used for simple conditional branching. It evaluates a condition and executes it based on the truth value of the condition. Here's the syntax of a conditional statement. So the conditional statement allows multiple conditions, and it has a default statement if none of the conditions are true. So here's an example of the loop construct being used. So the loop macros enable the iteration over code. It supports various looping constructs such as for, while, and do. So here's an example of do lists and do times. These are specialized looping constructs used for iterating over lists and repeating a fixed number of times. So expressions in lists are called symbolic expressions or S expressions. They can be evaluated to produce a value. So S expressions are composed of valid objects, atoms, lists, and strings, and any symbolic expressions is a valid program. LISP programs can be executed through an interpreter or compiled code. So the interpreter operates in a repeated loop known as the read, evaluate, print loop, and it reads the source code, evaluates it, and prints the resulting values from the program. The basic syntax of a Lisp expression involves prefix notation, which has the operator preceding the operand. In this example, we see the sum of three numbers, 7, 9, and 11, and the output would be 27. So Lisp expressions can be nested. When lists are contained within other lists, we have nested expressions. These can represent more complex operations and structures. So the use of nested expressions consists of like function composition, where you combine multiple functions in operation, data structures representing complex data structures like trees, control structures like defining control flows such as conditional expressions. And nested expressions are a powerful feature in lists that allow for the construction of complex programs and data structures. The recursive nature of list syntax makes it well suited for like tasks that involve deep levels of nesting. Program is a program that is written within a larger program to perform a specific task. And again, every list procedure is a function, and they help prevent the repetition of code as the same function is called from for different inputs. Functions are defined using the define macro, which allows user to create the functions. Any symbol can be used as a function name. However, functions names like typically include only letters and hyphens, unlike other languages that uses underscores in naming. The parameters, these are just variables that hold the arguments passed to the function when it's called. They are optional. If a function has no parameter, the list is empty. And the documentation string, it's just a string literal that describes the purpose of the function. And the function body consists of expressions that are evaluated in order when the function is called. Typically, the value of the last expression is returned as the function value. However, the programmer can return the function's value from any point within. So here's an hello world example. It does not accept like any parameters, and it just returns the hello world string. So Lisp supports object-oriented programming through the Common Lisp Object System, and the Common Lisp Object System provides a way to define and manipulate objects in classes. So classes are defined using the def class macro. It establishes a class as a data type, and here's an example of the syntax. So the slots are like variables that store data or fields. So each option in the slot description is a keyword, and it's followed by a name, expression, and other options. Here's an example of a rectangle class with 3 slots with height and color. In order for classes to be useful, their slots need to be accessible, readable, and writable. The programmer can specify accessors for each slot when defining a class. So creating instance of a class. The generic function make hyphen instance produces and returns a new instance of a class. So in this example, it also shows a method class being defined. So the def method macro allows you to define a method within a class. And in this specific example, the method is calculating the area of the rectangle. List allows you to define an object in relation to another object, which is known as inheritance. So the programmer can create a derived class by adding new or different features. So the derived class inherits the functionalities of the parent class. So in Lisp, the condition system serves a similar purpose to the exception handling system found in languages like Java, Python, and C++. However, it is more adaptable. Unlike exceptions, which are typically used for error handling, conditions in Lisp can represent any event that happens during program execution. So this just makes it more flexible, and the conditions can be of interest to code at various levels within the call stack. So the condition system is just more versatile than typical expressions handling systems because it does divide the process into like three distinct stages, which is signaling the condition, handling it, and restarting the program. So exception handling in Lisp is managed through the handler case and ignore errors construct. So they provide like a robust mechanism for dealing with runtime errors. And so the handler case, this just allows the programmer to specify different handlers for different type of errors. And the ignore errors is just used to execute code while ignoring any errors that occur.
In conclusion, Lisp is a highly expressive, flexible, and powerful language. It is particularly suited for symbolic computation, artificial intelligence, and research applications. However, its non-traditional syntax and dynamic typing may pose challenges for developers who are used to statically typed languages. So it just depends on what you need for your program.